I'm thrilled to be back this year at the world's best technical conference with the world's best technical community. This year with my pals James and Mike, with what I think is the longest talk title in ng-conf history. I had to take the opportunity to work as many buzzwords as possible into the title, but really we're here to share some interesting things we've learned about Angular and team productivity while working on migrating a big Angular JS app to Angular, or as we're calling it, turning an aircraft carrier. The slides we're going to go through draw from a sample project you can pull from Mike's GitHub, Mike Haas 763 / ng-conf 2019 turning an aircraft carrier. You don't need the sample project to get value from the presentation, but if you'd like to pull it down, tinker with it a little bit, ask us some questions afterwards, we'd be happy to answer. I usually talk very slowly, but since I made the very smart decision to try to jam 3 multi-hour topics into a single-hour presentation, I'm going to talk fast. I'm going to skip some points I would have liked to make. We'll do our best to leave some time for Q&A, but if you'd like to learn more, please come find us afterwards. We'd love to chat, answer questions, and share more info. So with that, let's jump right in. So a quick intro on me. I'm a platform engineering lead at Capital One. My teams are focused on UI architecture and continuous integration and delivery. Please do come see the Capital One booth to meet some of the team and learn more about the stuff we build, the Angular apps we work on. I've been building Angular JS and Angular things for about 6 years, with a significant amount of that time dedicated to migrating various apps from Angular JS to Angular. Tried a bunch of strategies. I framed some stuff in, upgrade module, downgrade module. So we're here today to talk about a new strategy that we're using. And I'll let James and Mike introduce themselves more properly in a bit. To set the stage, let's provide some background on the app that we work on. It's a servicing application. There are about 50 million or so registered users. Those customers can pay their bills, view their transactions, report fraud, etc. And there are multiple account types that show up in the application. So credit cards, checking accounts, auto loans, savings accounts, etc. A lot of developers and teams contribute to this app. This is where the aircraft carrier analogy comes in. We can think of the app itself like the aircraft carrier and the independent teams flying their own aircrafts to deliver value to customers. So a scalable federated operating model is critical for us. Teams need to operate independently without breaking each other's stuff while delivering what feels like a cohesive, seamless user experience in a single-page app. At the outset of this journey, the entire app was running AngularJS 1.3, and a significant portion of it still is. We installed the component polyfill a while back, which allows folks to think in a more Angular mindset, but we really want to get to Angular and retire AngularJS. Something interesting about this application, lazy loading has been required since day one, even as an AngularJS app, because there was too much to ship to the user all at once. So we've wired up lazy loading with UI router extras future states, OC lazy load, and that's using require.js behind the scenes. Find us afterwards if you're interested in talking about single-page apps versus multi-page apps, but for today, let's assume we're talking about a single-page application. We tried upgrade module on this project starting in early 2017, and then last year after ng-conf, when downgrade module was introduced, we tried that as well with limited success. And when we started this migration, we had 9 source code repositories for this application. When James talks, we'll hear about what that means and some alternative approaches that we've been adopting in terms of source code management. So with that background, how do we take this critical application from the starting point and turn the aircraft carrier towards a modern, scalable Angular app? For the first part of the story, I'll talk about our elements-based migration strategy. Real quick, I do want to say that we're not asserting that upgrade module, downgrade module, iframes, or whatever you do are bad things. This isn't supposed to be a controversial talk, just an informational one. We're just sharing a story about something that works for us. So with that, let's dive into using elements for Angular migration. With all of the available options for migration, how do we choose a strategy? We tried to narrow down to some key factors for comparison. Developer understanding was critical for us. To echo Igor's point from the keynote yesterday, we want developers to love building this app. So how do we support people writing Angular or AngularJS code when it makes sense with the minimum cognitive overhead? Secondly, we want to introduce Angular with the lowest possible effort and without breaking things. If you've read Victor Savkin's blogs or book on upgrade strategies, we considered vertical and horizontal. ultimately deciding to upgrade from the leaf nodes and then move up to the root component to keep things safe. Next, before AngularJS or Angular can do their magic, they need to be bootstrapped. And before they can be bootstrapped, they need to be loaded. Some of the questions we wanted to answer here include what's bootstrapping what needs to be loaded first, how do we limit framework mixing in our source code, and since we were already doing lazy loading in AngularJS, there were a lot of implications here. Rendering and change detection, obviously important. How do we get Angular components in AngularJS templates and or vice versa? And once you get both frameworks components on the screen, how do they update each other? And are there any performance considerations to keep in mind? Then there's dependency injection, one of the key features that AngularJS introduced to front-end development. Deciding how or if or when to share injectables is important. How do we keep the coupling light and, again, limit how much our code needs to know about mixing frameworks? And then finally, routing. Can we have both UI router and the Angular router running together? And if so, how do we determine which one of those things handles a given navigation event? When we look at upgrade module and downgrade module, I'm going to skip routing because we found that the answers to our questions were mostly the same between frameworks, but we will share it later because we think the approach is pretty cool. So, upgrade module, first path available to us. Let's look at how it stacks up with our key criteria. Let's start by looking through the lens of our most important factor, developer understanding. Taking a look at the upgrade module docs, there's a lot to wrap your head around. If we look at point 7.2, we can see that attributes in AngularJS templates use kebab case, while attributes in AngularJS templates must use camel case. That doesn't make sense. This is an unfair joke, and I apologize to the amazing folks that give us such wonderful and thorough documentation. I probably should have just opened a PR to correct this minor typo, but it served the purpose of this presentation, so I did not do that, but apologize to the docs team. There's a ton of smart folks building apps in the Angular community, but for me, keeping 9 points in my head at any given time, as well as my application logic, was a challenge. So if you're like me when working with upgrade module and your app doesn't do what you expect, you might find yourself asking, I'm going to leave that there for a minute because I like it. All right, what about our next key factor, bootstrapping? So this is an example stolen from the docs. We could see that Angular is responsible for bootstrapping AngularJS with upgrade module. This dictates our loading sequence, introduces some coupling and framework mixing, and means that introducing Angular is a global change, impacting the entire application, increasing the impact. Also, this one-liner may not seem like a big deal from a reasoning perspective, but when your AngularJS app is already supporting lazy loading, figuring out how to lazily load and instantiate AngularJS modules and components, etc., can be a pretty confusing thing. What about rendering and change detection? Well, the good news is with upgrade module, AngularJS runs in the Angular zone, so change detection just magically works. There is a trade-off here, though. Any change runs both the AngularJS digest cycle and Angular change detection, creating a potential performance bottleneck, but maybe that's a trade-off that we can accept. With rendering, it's a little bit more complicated. To make one framework's components available in another's templates, we use utility functions like downgrade component here and map inputs and outputs. So this was a little bit more mixed framework code than we really wanted and contributed to cognitive overhead. So in terms of DI, we made a conscious choice to only allow DI interop with AngularJS services being made available in Angular. We will get to that choice later. But in the interest of time, we're only going to look at that case with upgrade module when evaluating DI. Just know that sharing Angular injectables back to AngularJS requires calling a utility function and, again, adding some mixed framework code to your source code. Upgrade module makes the AngularJS injector available, so we can simply provide a factory that grabs injectables from the AngularJS injector. This is a perfectly reasonable, well-isolated thing to do, with the minor downside that our ng module is now aware of AngularJS things. When we look at elements, you'll see how we use the same principle of runtime availability of the AngularJS injector, but in a slightly different way that doesn't require our ng module to know about upgraded injectables, again, limiting the framework mixing. All right, and then last year we saw the Angular team introduce downgrade module, which was a tool for kind of flipping the control back to Angular JS. So maybe this was the solution to our challenges. I don't have time to do a deep dive on each key factor, but let's take a quick high-level look. On the plus side with downgrade module, we can lazily load and bootstrap Angular, which allows that leaf node up approach that we would like to take and limits the impact of introducing Angular. It does, however, require that we declare the downgraded module as a dependency of our AngularJS module. So we have, again, framework mixing in our source code. Change detection and DI get a neutral emoji. Downgrade mitigates the performance concern of change detection because AngularJS is not running in the Angular zone, but we need to explicitly initiate cross-framework change detection, which increases the cognitive load and, again, mixes framework synchronization into our code. In terms of DI, downgrade module's benefit of lazily loading Angular things comes with a trade-off. Each downgraded module is treated as a root, meaning that if we downgrade multiple modules, we need to explicitly pass the root injector to our module factory's create functions. In fairness, we do have to do the same thing with our elements approach, which is why this is a neutral rating. With either downgrade or elements, you can and should take that boilerplate concern off of developers' plates with the schematics magic, and James will talk about that in a minute. On the negative side, when we were starting this effort, an app could only have one downgraded module. This was kind of the hard stop for us when considering downgrade module, given our contribution model. And I think support for multiple downgraded modules landed in October or November of last year, but we were already well on our way with elements. In terms of rendering, we still would have needed to use upgrade and downgrade component utility functions and use those wrappers, which increases the cognitive overhead and, again, mixes framework concerns into our source code. Lastly, our most important factor of developer understanding is not helped much here because the frameworks are still interacting quite a bit. But then along came the elements package. This probably is not the use case that you've heard about in the context of elements. More likely you've heard about dynamic content or putting Angular stuff in an app owned by a different framework. But if elements means that you can put Angular things in an app owned by another framework, why not an Angular JS app? So I asked Rob Wormold this question last year, and he said, yeah, you could probably do that. That's not really what the tool is for, but go ahead, give it a shot. So let's look how it fit our goals. Before diving into migration with elements, just a quick overview of elements on their own. Hopefully some of you saw Manfred's talk yesterday, explained elements much better than I could. I think he's got another workshop today. Advise checking that out. We're limited on time. We want to focus on the upgrade strategy, so I'm going to do my best to describe elements in 2 minutes. What are elements? In short, they are Angular components packaged as native custom elements. We can think of elements kind of like miniature Angular apps. The host app and consuming developers don't need to know about Angular. They can just put a DOM tag, like regular old custom elements, into their template and expect it to work. So how does this work? Elements bridges Angular things to native APIs. So Angular semantics and constructs like input and output are mapped to native browser APIs that any app can understand and consume. To further illustrate that elements are separate and apart from Angular, we can look at the globals that are exposed in all modern browsers and can be polyfilled in others, where we have this custom elements define function that accepts a tag name and a class that usually extends an HTML element class, like a paragraph. It's almost a lot like creating Angular JS directives back in the good old days. You call a function, you pass a tag and a configuration object, and then you can start using your very own HTML elements in your application. The Angular magic happens here by importing and invoking the custom elements, the elements package, create custom element function, and passing that return value to the custom elements define function as the second argument. Again, for more and better info, please check out the guide, and hopefully you got to see Manfred's talk yesterday. All right. So how does this actually help with our key migration considerations? Migration with elements really shines in the area of developer understanding and the mental model. Since elements are plain browser-native components and they bootstrap and destroy themselves, we don't need to think about which framework is bootstrapping the other one, how to upgrade and downgrade components, and how and when to invoke change detection routines to sync across the frameworks. We simply build an element, put that elements tag in our template, and make sure the element bundle gets loaded at runtime. And that's it. And this makes Ron a little bit happier because it's simple to understand. All right, so in terms of loading, how do we actually get elements bundles into our application? Well, you simply use some imperative API to load the correct UMD bundle. In our case, we already had OC lazy load and require.js wired up, so that's what we use. Most often, we do this in resolve blocks in our UI router state definition. So we have an AngularJS route. We put a resolve statement in there, and then we use OC lazy load to go grab the bundle that we want to use. In Rob's talk yesterday, you saw that there are maybe more elegant ways to do this with dynamic imports, but at the end of the day, you need something that's going to say, go ahead and load this bundle. Let's take a look at what is actually in that bundle. In terms of ng-module and components and all that good stuff from Angular, nothing changes from a plain old Angular app. And the bootstrapping process for our elements module has no knowledge of AngularJS, which is a key point for us. In the main.ts, for any given module, we hook into the on-app bootstrapped lifecycle event, ensuring the shared injector is available. More on that in a minute. From there, we create a module ref by invoking the create method and pass the shared injector. Then we invoke the only method of our team's elements module, create and define elements, passing that injector. And we can look at that method in more detail. It loops through the Angular components that we want to expose as elements, defines the custom element with the shared injector, and the strategy factory to wire up automatic change detection. And we'll look at that in more detail in a second. Then we invoke the custom elements.define function and create custom element to make the tag available to the DOM and hook up Angular. And in terms of loading, again, we can lazily load this whenever we want. What about rendering? Once we've registered our custom element, we can simply drop it into our AngularJS template. There's no utility functions that we need to call to make Angular understand AngularJS things or vice versa. We simply make sure that the element bundle is loaded and we can use the tag in our template, which is a fair amount simpler. For change detection, we do need to do a little bit of extra work. In AngularJS 1.7.3, some helpers were introduced for binding properties and events to custom elements from surrounding AngularJS code. But as I mentioned, we're on 1.3. We're not investing in any AngularJS upgrade, so we use the ng-custom element library that our pal James wrote, which gives us the same functionality and is available on NPM. Additionally, when we create our custom element, we're passing a strategy implementation, which wires our element up to the root Angular apps zone. This achieves the same automatic change detection effect that you get with upgrade module, but it also provides the downgrade module perf benefit of running Angular change detection for one framework without necessarily triggering the other. So they're isolated from one another the same way they are with downgrade module. What about DI? So there are three cases here: sharing injectables between elements modules, exposing AngularJS services to Angular things, and vice versa. We chose not to bridge Angular things back to AngularJS because we want to encourage retirement of the AngularJS code, and it makes our head hurt. In the case of sharing between Angular modules, we follow a very similar strategy to the one now supported by downgrade module. We bootstrap an Angular app. That creates a root DI container. We expose that root injector on a global variable. Then when we bootstrap our elements modules, we pass that shared injector to the module factory's create function, and that sets up the same relationship that you might expect in any regular old Angular app, where you have hierarchical injectors. What about sharing AngularJS things with Angular things? For example, if I have an AngularJS service that contains my internationalized content, do I need to rewrite that before I can create any Angular components that rely on translations? For this case, we created an Angular FrameworkBridge service that leverages a very similar strategy to the upgrade package and the runtime availability of the AngularJS injector. Let's look at that in detail real quick. So our FrameworkBridge service has a method called getAngularJSResource, and that just grabs injectable instances at runtime. So we can bind them to props of other Angular injectables or properties of our components. Our ng module here, again, has no knowledge of AngularJS, which is a key point for us. You might be asking, isn't this like the framework mixing thing that you want to avoid? But the key difference here is that the FrameworkBridge is an Angular service. The fact that it talks to Angular JS is just an implementation detail, and the framework bridge could be doing anything behind the scenes. The code leveraging the bridge doesn't need to know about it. So we offer a couple patterns here. We can expose the Angular JS injectables directly on our components, or we can wrap them in Angular injectables that act as facades, and each of these has its benefits and trade-offs. In a picture, exposing directly might look like this. We use the framework bridge to grab an Angular JS injectable and bind it to a property of our component. In the wrapping strategy, we create Angular equivalents of our Angular JS injectables, but those injectables are simply facades. They delegate directly to the Angular JS injectables. This is nice because it means our components are unaware of the bridging, so when we're ready and we have the appropriate Angular services migrated, we can remove the bridging without any impact on our individual component code. Mentioned earlier that I was skipping routing and upgrade and downgrade module because it was similar in all approaches. We were not in a position to migrate all routes in one fell swoop. We needed to move incrementally and run both UI router and the Angular router in a single app. So how do we make it work? First, we put sibling elements on the page. One is UI router's root UI view. The other is treated as the Angular router's root outlet. From there, we configure both UI router and the Angular router with empty kind of catch-all routes. When the Angular router sees a route it doesn't recognize, it renders simply an empty component in its outlet, and the same goes for UI router. So in all cases, there's precisely one router handling a navigation event. A big caveat here, I have not seen the dollar location exposing that's going on in Angular version 8. That might be way better and smarter than what we are doing, but this approach works for us for now. So in summary, why would you choose to do this? We found that it's simpler to reason about. Developers can understand what's going on, focus on making things and delivering value rather than trying to figure out which framework is doing what at any given time. A lot of this simplicity comes from the good old principle of separating concerns. So Elements allows us to bootstrap and load Angular and Angular JS items whenever we want without one framework knowing about the other. There's no wrapping components in the other framework's conventions, no wrappers to map upgrade component AngularJS to outputs and Angular outputs, no creating AngularJS directives for Angular components via downgrade component. We simply slap a tag in the page and everything works. We don't need to explicitly invoke change detection in either framework because we've got that strategy factory that we implemented that makes that happen automatically. And we can inject AngularJS dependencies into our Angular code in a fully transparent way without impacting the existing AngularJS code or our ng modules. Because of this separation, we were able to make low impact, light touch changes to introduce Angular. If you want to learn more, check out TJ Seaman's Medium post, how Capital One is using Angular elements to upgrade from AngularJS to Angular. Now, making these changes in a situation where you have source code across 9 different repositories presents a whole new set of challenges, which are agnostic to any framework. So to talk about the strategies that we're employing to make that a little bit more convenient, I'm going to hand it over to James.
Thanks, Dylan. Because I'm a massive idiot, I just drank all my drink while I was sat there, so I'm suffering from conference throat a little bit, so my voice may crack at various points. I'll do my best to battle on. This is Dylan's laptop, so hopefully just, yeah, cool. So as Dylan mentioned, when we first started this project, it wasn't just a case of figuring out how do we make Angular and AngularJS work, how do we upgrade. It was also the case of dealing with the fact that we're building one application. As you heard, we have 50 million users. There's 300 developers working on this. That implies a lot of hierarchy and a lot of cultural things just to go into making one application. So it's not as simple as figuring out the technical details. We have to figure out how we can work together to make this happen. And the reality is, of those 300 developers, not everybody is going to have the same in-depth understanding of all of the migration process. So we need to be able to facilitate developers being effective and efficient, not reinventing the wheel, working together, and not being exposed to necessarily every single implementation detail within disparate repos spread across the organization. So I'm going to focus my section on code storage and code structure, and how those actually impact collaboration within an organization. So it's highly related to, again, like the way we're framing this is our experience of doing this together. So my name's James Henry. I work for a company called Narwhal, the unicorn of the sea. And I have a passion for open source tooling. I'm heavily involved in TypeScript. I'm a Microsoft MVP on the subject. So I've worked with ESLint, Babel, and Prettier to support TypeScript in those projects. At Narwhal, we try and help folks develop like Google. Google is a little bit of it's an example of the kind of things we approach things like. Google is an extreme example of some of the best practices we try and promote. So I've been working now with the Capital One folks for about 11 months, and it's been a really cool experience. You can catch me online, jameshenry.blog, typescriptcourses.com. I occasionally do stuff online. So let's talk about what enterprise team wants. They want to not reinvent the wheel over and over and over again, because that massively impacts both developer productivity and also a sense of well-being, I feel like. If you're looking at something which is almost identical to the thing you need, and for reasons you can't control, you have to re-implement that thing from scratch because certain things are slightly different, that can be quite a frustrating experience. You want to build features which are going to impact customer experience. So we want to not reinvent the wheel. We also want to be able to share things. We want to develop things which are consistent across the organization, so we want to be on brand, as you might say, and yet we still want to preserve that team autonomy. We still want to be able to feel like we're an important cog in an overall machine. They're not easy challenges, and I want to talk about how code structure and code storage can affect those goals that organizations might have. So in order to illustrate this point, I'd like to talk about the extremes of the spectrum. So in terms of code storage, how you locate your code, the extreme ends of the spectrum would be extreme monorepo and extreme polyrepo. In other words, keeping every single line of code you have in one repository, having atomic commits, single versions of dependencies, and this might be something where you think of Google, for example. They very famously have effectively one huge repository for all of their code. And on the other end of the spectrum, you have everything is split into different repositories. So every single repository needs its own builds and publishing and CI concerns. It needs to work out how it's going to version things. And then only later down the road, you have to figure out how you can wire things up. When it comes to code structure, we can think about monolithic apps and more modular apps as being the two sides of that spectrum. Notice this is a different spectrum to code storage. So a monolith would be that our code is written in a very context-dependent way. It's not easy to separate concerns. It's not easy to draw boundaries between things. It's not easy, therefore, to reuse things in other similar contexts. Modular, however, might be considered that you've drawn clear separations of concerns around things. You've got clear module boundaries. You have explicit APIs between things in your application. You have clearly exposed public and private implementation details. I've got a little illustration of maybe what this might look like when you implement an application. On the left, we have an example of something that's more monolithic. So if we look at the dark circles there, those are meant to be the types of code you write which are actually specific to this application. Every single application, no matter how it's structured, has some logic or some kind of components, things like that, which are specific to that application and that application alone. That's only natural. However, we do have certain things, which are represented by the colored boxes here, that are arguably generic. They could be, for example, presentational components or dumb components, which just take inputs, render things, they produce outputs, but they don't need to know what context they're being used in. And you can have common data access libraries. You might have multiple applications in your organization which access the same set of APIs, for example. It's a real shame if you have to keep implementing wrappers around those APIs over and over again. But if you write your app in a monolithic way, you can end up losing any ability to extract some of that logic and reuse it in other applications. On the right-hand side, a more modular approach separates those concerns into the kind of responsibility that they have. So data access libraries get grouped together. Components that are shared get grouped together. And then business logic for a specific app is also categorized as such. I want to just stress, so it's super clear for everybody, that a monolith and a monorepo are not the same thing. As I've explained, I've highlighted it through two different spectrums. The monolith is related to how code is structured. The monorepo is related to how code is stored. You can produce any effect from any storage, effectively. So you can produce a monolith from a polyrepo approach and vice versa. It's possible for all things. So It's not to say that things are entirely unrelated, because I'm specifically talking about a section that is about code structure and storage and how they relate to collaboration. But I want you to bear in mind that just because they both start with mono does not mean they're the same thing, and it's important to bear in mind. So just as a quick visual analysis of what we might think of as examples of these things I'm describing, we might think of Google as the extreme monorepo. So we have monorepo, we have our code storage on the y-axis here, and we have how we structure our code on the x. So Google, extreme monorepo, but very modular. They have fantastic engineers, they have unlimited resources effectively, so they can approach their code in a very scalable, modular way. If we look at maybe the open source on GitHub equivalent, this is indeed pretty modular because everyone's separating out their code based on it doing one or a couple of things. But it's a very heavily split approach. Everything's in different repositories. So it's up to you to then stitch things together. It becomes a bit harder to share things in an intelligent way, in a precise way. And in our experience, what we see is that a lot of enterprises end up roughly here. So they end up with quite a monolithic app. It just organically ends up that way because there are all kinds of constraints. There's all kinds of feature delivery deadlines, that kind of stuff. But we're also on the polyrepo side of things. It naturally ends up that teams want to control their own destiny, so it might be an obvious thing to do to create a separate repository for that. Our thesis, however, is that monolithic polyrepos, in other words, that position on the graph where a lot of enterprises find themselves, is actually the enemy of collaboration. And I'll expand on that now. So with monolithic polyrepos, we do have that autonomy, but we do lose that ability to meet some of those goals we described that enterprises want. It suddenly becomes very difficult to ensure consistency across the enterprise. And for tooling and other concerns, it can be incredibly difficult to ensure versioning, publishing, CI, all of that kind of stuff. It all has to be repeated. I'm going to illustrate this with a very basic example. Mike is going to talk more in depth about components and those kind of shared use cases. Mine's just an illustrative example. Let's imagine we have a button. Let's imagine Narwhal has invented a design spec, and we define this beautiful button. And it defines some padding and some fonts and whatever, and that's what we've implemented. But then it's up to engineers to implement it. So this might be the reality of what ends up in users' hands. So we have multiple applications. The teams that have implemented it are in different repositories, and there's a number of reasons why we could end up with this. Like, you can tell these are the same button. They have the same characteristics, but clearly they're different. And naturally, as users, our eyes are attuned to picking up even the slightest differences, and it's super annoying. So how did we get here? Maybe the spec was ambiguous. Maybe the authors of the spec didn't do a good job of defining all of the things in crystal clear detail. It could be that there were just time constraints and details were skipped, or one team wasn't as detailed as another when it came to implementation time. There's all kinds of reasons why this might come about, and it's not really anybody's fault. But my point is that it's easier to do the wrong thing when you're spread across these polyrepos. So that's just a summary of what I've been saying. And the other concern, naturally, of course, then, we have this button, which is fulfilling the exact same use case. But because we've chosen a polyrepo approach, we have to independently define a CI process, a testing process, a build process, a versioning process, all of these different things to then bring down into the application. So this could be done inconsistently. It wastes a massive amount of time because not only have we implemented the thing twice, we now have 2 different release processes for the same thing, effectively the same thing. It's not a shared implementation yet. So again, I would just like to reiterate that with polyrepos, it's easier to do the wrong thing. Ultimately, everything we do as software engineers, we're dealing with levels of abstraction. The most efficient way we could work with computers is to write binary. We could write zeros and ones, and we could tell our computers exactly what we mean. But we've invented all kinds of levels of abstraction to make it easier on ourselves to do efficient things, because if we were directly writing machine code, we would blow up our CPUs, probably. We're terrible. Like, humans are not good at that kind of instruction set. So the reason we deal with these things is to make things easier for ourselves, to not do the bad things. And with polyrepos, it's just fundamentally easier to make these mistakes. So what if the team had a monorepo? Well, suddenly our applications that we have, the homepage and the admin app, they're right next to each other. So let's say homepage app already implemented the button. It suddenly becomes obviously wrong for the admin app team to re-implement that button because it's right there. It would be so obviously wrong to do it. Not only do they not have to re-implement the functionality of the button, they're in the same repo, so they don't have to invent a new CI process, build process, test process. Because the applications are then also co-located with the button, it's not like a shared component repo that publishes artifacts that get consumed into the app. You can also do far better integration testing. Unit tests are fantastic, and they make us feel warm and fuzzy inside. We can see coverage numbers, and they go up, and we can reach 100. But then we plug it in, and then it breaks because we don't have good integration testing. Suddenly, with a monorepo, it's trivial to do good integration testing. All of your commits can test across all of your applications. So fundamentally, it's easier to do the right thing. You might be asking, what happens if I want to make a change to the button? Now I've lost all control over the button, and previously as the admin team, I could write my own button and I could change things. That's true, but as we've said at enterprises, we want consistency. So if you want to make a change to the button, that might be a good thing, but it's a good thing that you have to have a discussion with your colleagues and work out what the best solution is for everybody. I would say that this is a good tension to have. So those are the problems. Hopefully now you understand how we're positioning structure, storage, its effect on collaboration, and particularly on enterprise teams. How do we solve these problems? Well, Narwhal produces an open source toolkit called NX. So you can go to nx.dev. We've got brand new documentation. We've got lots of rich guides and stuff like that for understanding a lot of the things I've described, and then how to implement these things and solve some of these problems with NX. So this is completely open source. You can see how it's implemented. You can contribute. Please do. And if we have an NX monorepo, it's kind of roughly here is how I position it. So we're not full monorepo in the sense of it's not the tool for you to power your entire 10,000 person organization with every single back and front end app at this point. You've been hearing a lot probably at this conference about Bazel and its power, because it's the open source variant of Blaze, the tool that they use inside of Google to power their giant monorepo. NX is not quite that. NX is positioning itself to do 90% of the work that Bazel would be able to do, but in a different way. So with Bazel, you annotate your workspace with build files. So you say, this is a part of my application. I only want to rebuild this part when I make a change. You do that explicitly, so it's far more powerful. But with NX, we were able to infer the relationships in your monorepo through imports and export statements, through your source code. Because it's TypeScript, we can statically follow those import and export paths to build up what's called a dependency graph. And this is a key requirement of scaling a monorepo. The advantages of co-location and stuff like that will fall down if, on every single change, you rebuild the entire universe, because that will be very slow. So we need tools like NX to be able to provide that kind of power on top. It's fundamentally powered by the Angular CLI. So it's not a brand new concept to you. It's not something that you need to learn specifically. NX is powered by all of the same structures that the Angular CLI is, and we call it directly behind the scenes. So monorepo and modularity is what we're striving for, because we've decided those are the optimal things, as I've discussed. So in a standard Angular CLI setup, you'll have a single source directory. The Angular CLI does now support multiple projects, but by default, you will have one project out of the box. With NX, it's always been focused on a monorepo approach. Even if you only have a single application, however, the approach and the breakdown of having apps and libs is a really powerful approach. So what's the difference between apps and libs? Well, if you remember my diagram with the circles and the squares, we do have different types of code. Not all code is exactly the same. So with our applications, with our apps, this is the wiring up point of a specific thing we want to deploy to users. That's all it is. All the rest of our code goes in libs, and we categorize it based on what type of code it is. So for example, here it might be common UI, it might be data access things, or it might be application-specific business logic, like I mentioned. Here we have a library called narwhal.io because it's code that's specific to narwhal.io's implementation. So that's how you can think about the separation from libs. If you're NX users already, a best practice with NX is to make sure as much of your code is in libs as possible, because that gives you the ability to be modular. That allows you to draw those explicit boundaries and have public APIs for your code, which the rest of your monorepo has to respect, because NX provides tooling to ensure that you stick to those public APIs. So having those things next to each other and having those enforced best practices around sharing means that you have first-class reusability and consistency across your code base. As I mentioned, the only way to scale a monorepo is if you have a tool which is capable of understanding your dependency graph. So here I have an example, a very simple example, we have an admin app and a client app. So both of these things have end-to-end tests. So those actually, in our dependency graph, those actually sit above our application because they depend on our application. If our application changes, our end-to-end tests need to run. But the other things that make up the application sit below them. So here, our admin app is made up of an admin feature that was implemented called permissions, and also some more generic stuff like a data access library. Both our applications share a library around components. So they have some DOM components which are consistent across our organization, so we just share them. And as you can see here, the ones that are highlighted in red, this is actually a visualization that NX will generate for you. You just need to say, generate my affected dependency graph, and it will literally create this diagram for you. It will highlight in red what's affected by your particular commit, for example. If I make a commit which changes the admin feature, I have affected the admin feature itself, and the admin app end-to-end tests. Those are the things I need to rerun if I've made a change to the admin feature, but nothing else. I haven't touched anything to do with shared components or the client app whatsoever, so I don't rebuild that, I don't retest that, and there's no integration points there for me to worry about. This is the only way to scale a monorepo. If you seek arguments against monorepos, they will usually be the result of the fact that tooling falls down in this area. You end up with hugely spiking build times and stuff like that. You need something which can enforce dependency graph analysis. Just to show you an example of the kind of commands you run off of this information, we provide some npm scripts out of the box for you to invoke, but ultimately this is just invoking NX affected behind the scenes. And we have some options of how you determine what range you're looking at. So you can use commit chars, or you can use untracked if you've just got some work in progress you haven't committed yet. You can just see between these 2 points in time what's affected. And only rerun the test, only rebuild, only rerun the end-to-end test for that period. Cool. So very briefly, because there are many talks on this topic specifically, I just want to talk about some of the key aspects of the Angular CLI that we actually leverage for NX-powered monorepos. And specifically at Capital One, we're using quite a few of these as well to power our elements use case. So I'm just going to switch over to, let's go over here first. There we go. I think I'm going to need to bump this. So this is the sample repo that Dylan mentioned before. So just very quickly going to use it to highlight some of the examples. So come in here. Angular JSON is an incredibly powerful piece of configuration. It's actually the architect stuff which came in version 6 is hugely, hugely powerful and very generic. It's actually, even though we use it for Angular, it could be used for any real use case. We have our projects, which is our top-level object here, which defines all of the different pieces of our monorepo. Each one of those projects has an architect. This is very difficult for me to lean around here and do this at the same time. Everyone has an architect's property. So this architect's concept is where we define references to our builders. And a builder is just a way of running a command or kicking off a compilation process, running linting, testing, those kind of things. It's a very generic concept. Each architect type, or target as it's called, is given a name. So build, we have, if I scroll down, serve, extract i18n, lint. These are the things which power you running ng-lint, ng-build, ng-serve. It actually translates into architect targets. As you can see with lint here, it has a builder. Extract i18n has a builder. So once you've understood architect and how that fits together, you then need to understand builders. So builders, out of the box, Angular ships with all the builders you might need for a standard Angular setup. But you're not limited by that. You can write your own builders and just swap in the reference here. So by default, they come from Angular Dev Kit in your node modules. But you can write your own builders and just reference them via a relative path. By default, NX provides a tools directory, and in here we have builders. So in our particular case, because we have some interesting concerns with how we wire things together for elements, and we have that independent team methodology that I described before, we want to be able to do something subtly different to the way Angular CLI builds things. We need to build UMD bundles of all of our elements and share them at runtime. So we make a tweak to the builder. So we provide our own builder. You don't need to worry too much about these implementation details, but for example, right now it's this simple. So unfortunately, huge caveat, In version 8, the builders API is changing, so don't look too hard at the implementation details here. But the concept here is that we use the underlying Angular browser builder, so the one that would be in that config by default. We slightly extend it, override some of its behavior, in this case, how the Webpack config is being written. We slightly tweak the Webpack config, and then we're done. It's a class which behind the scenes has a run method which returns an observable. This is changing to be just a function in version 8. But right now, this is how we do this in our real application at Capital One. We extend the base one so that we know we're not reinventing all the hard work that's been done by the Angular team, and we just tweak the Webpack config for our own usage. So that's architect and builders covered. Schematics are a fantastic tool. We're actually running alongside a schematics workshop right now, I believe, and there's several other talks at this conference about schematics, so I'd encourage you to check those out. Essentially, it's a way of making sure that the best practices you decide for your monorepo as they evolve are stuck to by engineers. So by default, you're used to the ones of ng-generate components and stuff like that. It's all powered by schematics. So you're generating things on your file system in a specific way. You might decide, for example, that you have particular conventions for your own schematics. Right now, we don't have an example in this repo, but with NX, the tool I've been describing, we have many schematics that we provide out of the box, just like the Angular team does. So if I come down here, this looks quite intense. Is it all the way down the bottom? There we go. So it exports a default function. There's some concepts here that you can look into, like tree, for example, is a key concept. It's like a virtual representation of your file system. So you can apply changes and things to your file system virtually first before they get committed to disk. So you can write really nice unit tests and stuff like that around your file system behavior. But essentially, you're returning a chain of instructions. So for example, the key thing I wanted to highlight here before I finish is the fact that when we do a narwhal library, a lib, all we're doing is invoking the standard Angular one. We're invoking what's called an external schematic. So we're invoking somebody else's schematic with a particular set of options. So the same way as if you've gone ng-generate library, this is what we're doing programmatically here. And then we make some tweaks to it. So we move some files around, we update some files, we choose to provide jest out of the box. We like jest a lot, so we provide it as the default, but you can choose what test runner you want to run. So schematics are hugely powerful. If you decide at your organization, I like to do this way, you can write a schematic, use it locally using NX, and enforce that best practice in your monorepo. And like I said, out of 300 developers, only a handful need to care about the implementation details of this because they can just run ng-generate my.org component, and it will generate a component with the styles you specify. So with that, I will pass it over to Mike. Oh, I'll do you a favor and get that. Oh, no, I won't. You can do it.
I'll do it. Wow. This was a pretty good turnout, so thanks, everyone, for coming out. I don't have my notes. Sorry, just 1 second.
Over here and try swiping over there.
My bad.
Thanks, James.
Hit escape. Present. Hover at the bottom. Presenter view. Grab that. Command Control F. There you go. Click that.
Click this. All right, quick bit about me. I'm Mike Haas. I'm a team lead at Capital One. I love TypeScript, type systems in general. I love Angular, even though I work at, in addition to Angular, I work on other front-end frameworks at Capital One. And I love Monorepo, all the things that James was just talking about. So at Capital One, we want to, I guess I shared with you our journey toward building a Capital One branded UI component library on top of the component dev kit library, also known as the CDK. To encourage a great inner source contribution and collaboration model, we've set it up as a project just like any other NX or CLI-based project. Since this project is such a heavily shared project with many dependents, it was extra important for us to optimize our test tree using NX affected, just as James described before. Additionally, as a quick explanation for those who do not know what the CDK is, it is a library from the Angular team that provides foundational building blocks for building out consumer-ready UI component libraries. There are no visual design assumptions within the CDK. It essentially pulls out the things that are common between all UI component libraries so that we don't have to re-implement the same logic across all these different libraries. In fact, the Angular material library utilizes the CDK under the hood. Like most websites, when we started building out the Capital One platform, we immediately had this need for components so that we had a consistent look and feel, along with all the other great reasons to use a UI component library. So we started with Bootstrap components via the UI Bootstrap library, like I'm sure many of you have used in the past. As a matter of fact, when I was creating these slides, I was kind of reminiscing and feeling a little sentimental because it was like the first library I was using when I was learning Angular JS. As noted in this slide, these components that we started out with are Angular JS components. So we're at a point in history of our journey where our platform was just kind of 100% Angular JS. Bootstrap is really cool and something I've utilized heavily on past projects, but we are a company with an established brand, and we wanted to reflect that with our components. We started out by overriding Bootstrap styles, but that became hard to maintain and resulted in visual design defects. It also didn't give us the full flexibility that we wanted that we'd get with our own implementation. So we set out to create our own shared UI component library. If anyone here has an account with us, you've probably seen a dialog that looks a lot like this before, because this is a real reusable component that we created for our shared component library a few years back. It worked well for us, but we were responsible for writing and maintaining the code to manually inject our dialog into the DOM, creating the backdrop overlay that is behind it, and preventing focus from leaving the dialog to enable a good accessibility experience. All of this code was coupled to the dialog itself, the consequence being that we couldn't reuse these generic functionalities with other components that we were building, such as our tooltip component. Over time, our set of custom reusable components grew and matured to a point where we could build most features utilizing these components. Now, relating to our journey from AngularJS to Angular, we of course needed to upgrade our shared components. However, we wanted to take our learnings from the first time around. Since we became aware of Angular material, we wanted to look at that project through the lens of the Capital One branded components. So quality. What we saw was that Angular material components were high quality from at least two perspectives. They are high quality because they provide a great end user experience, but they also provide a great developer experience. They contain excellent documentation with an easily accessible documentation website. The components are highly declarative, leading to something that is very understandable for engineers. The programmatic APIs are also intuitive and understandable. Those are all great qualitative observations, but something else really caught our eye. When digging through the material source code, we found some very awesome and generic abstractions. I'll give you some examples. When I showed the Capital One dialog earlier, I mentioned that we needed to write code that would prevent the focus from leaving the dialog. This is for accessibility purposes. It's very important. Doing so involves a fair bit of code, and it's not something that a typical engineer would be able to do without investing research time into the DOM APIs to see what's possible. We found a useful little thing in the Angular material code base called focus trap. This directive allows us to easily trap focus with any DOM container element. I'm talking almost no effort. It's just slap a directive right on there. Another very useful but internal abstraction that we found was portal outlet. I'm going to go a little bit faster because we're running out of time, but this allows you to kind of define a slot in your DOM anywhere and then insert programmatically another component into that slot. It's a little bit different than like transclusion or content projection because those are declarative. This is a programmatic and more dynamic capability. So back to our Angular migration journey, we needed to start implementing our shared components, and we wanted to use these abstractions, but we couldn't, and that made us sad. Since we want our own branded components, using Angular material was out of the question. However, the abstractions I previously talked about are not inherently coupled to the material spec itself. Additionally, they weren't coupled to the rest of the material components at a code level. Since APIs were decoupled, the thing that was preventing us from using them is that they were internal private APIs of the Angular material library. The Angular folks saw that others wanted these abstractions, so they released the CDK. It includes these abstractions as supported official public APIs upon which others can build their own branded shared components. Since they released this CDK, we've been empowered to build several of our components more quickly and with more confidence than had it not been available. Additionally, since the material components are such high quality, we've taken a lot of inspiration from most implementations that are above and beyond what's in the CDK itself. I think it's awesome that they're working on the CDK, and I can't wait to see where it goes. These are all the different components that they have today. As James was describing, we use NX so that we can get the benefits of a monorepo. So you may be asking yourself why I just spent time talking about the CDK. Well, it's because it's like a perfect example for what we can do with NX tooling. I'll try to show you with a real use case that we have at Capital One. Once you have your repo and your Angular project NX enabled, you end up with two CLIs. Generally, you'll abstract that behind npm run commands, but I'm going to go right for what the commands are so you can see what's happening. You will use the ng-CLI just as you normally would to serve your app or to generate code artifacts like components and services. However, if you want all of the intelligent affected build, test, and lint functionality, as well as the ability to run in-repo custom schematics, you'll use the nx-CLI. So here's a quick example of how we actually use it from the command. So ng generate library components. So I want to generate a library for components to store reusable components in. And then we get a little project like this. ng generate library card payment. So this is like a feature component that we want to build that will depend on the components. Now, this is where we were talking about before. We have integration points using custom elements in order to upgrade our app. So we created a custom schematic that generates a project, and then we'll also wire up a component that's already a custom element. So this saves our developers the cognitive overhead of understanding that. So if I make a change and I want to run the build, it will only run on the projects that I've changed. In this case, it's affected, and then you specify a target, which is the project, or which is the architect, and then you specify base master generally in order to run just your changes. Now let's say I made a change to the shared components library. That's cool, but now I need to run the build on that as well. So the affected tooling just kind of takes care of this for you. And additionally, what if there are other features that are already out there? It will automatically take care of that too because it's just traversing the TypeScript imports. And then here I just wanted to show, so obviously that's building, that's cool, but we also want to run the affected tests. So here I've changed the target to test, and it's kind of the same exact thing. So we're running out of time, so I'm going to turn it over to Dylan. Thanks.
All right, thanks everybody for coming. Hopefully there was some useful information for you here. If you want to hear about elements migration strategies, why we are making 300 people work in the same source code repository together, or how the CDK is helping us accelerate our Angular migration, please come find us and check out the repo. We'd love to share some info. Thank you.